So as you can see, everything is going to be recorded. And later the link is going to be shared to every one of you. So you are welcome. So you are welcome. I am Yusuf Musa by the name, a staff of the Department of Physics, Bayero University, Kano, Nigeria. I'm an academic staff specialized in geophysics. I'm a geophysicist. Same time, I'm a physicist. So these are my contact details. The email is this. My website is this, and this is, you can get in touch with me through WhatsApp. And that is just about me. Then the essence of this training is for you to able to master it and able to do it by yourself. So this kind of analysis that require a lot of steps that one needs to be able to carry out analysis. If I give you an example of one of my paper, as you can see, this is one of the paper I'm about to publish. If you can look, if you scroll down, you can see this is a study area. And in most of the cases, people send somebody to do them the study area map, and that is another wrong approach. You can do this from scratch. So this was created by me from scratch. And also the geological map. You can see the geological map here was also created by me from scratch, which was adapted from NGSA 2008. And you can see a lot of analysis here, TMI, regional, residual, contour, phase vertical, Euler deconvolution, 2D profiling using GIMSys, and so many other stuff. So these are some of the things that you also need
Please,
to
we can't
know
see your
about.
screen. Sorry for the...
You said?
We can't see your screen.
Sorry, I'm sorry. I'm sorry. Let me see. You can't see my screen?
Yes, we're only seeing your photo.
Oh, maybe I've talked. So now, can you see the screen?
Yes, the screen does appear.
Okay, now. Okay, so let me take it again. My name is Yusuf Musa. I'm a staff from the Department of Physics, Bayero University, Kano. As you can see, these are my contact details about me. In case you have one or two questions, you are free to get in touch with me. The essence of this training is for you to have one-on-one so that you are able to master it, powerful, and able to do something by yourself. You don't need to dedicate the work to another person to do it for you. Do geological map, all these things can be done. I know there is so many stuff, and this is one of my paper, which involve a lot of stuff. It's just about modeling, which is part of, not, even though it's not part of this, our training, it is on the separate part on itself. Then I also engage in also another part of this. You can see I do some kind of land site. As you can see under my land site, these are some of the work I've done. This is the crustal techniques in mapping the thermal zones. So those are some of the work under Landsat, where you can able to integrate Landsat with Aeromagnetic. And this is Aeromagnetic, some of the stuff that we are going to be doing in this training. We have the analytical signal. Right, can we start from the TMI? So you can see this is one of the things that we are going to do in this course. You can see the TMI, this is a TMI, well professional. If you zoom, you can see the resolution still remains the way it is. It is professional with all the study area map on it with the legend. And if we go back to the study area map, how to design something like this, how to have your source parameter imaging, so this is the spectral block for spectral analysis. This one is an advanced way of doing the spectral analysis. All these things were done through ArcGIS and QGIS. At the same time, this is the spectral analysis, which also we're going to do, which will allow us to do it right inside the Oasis Montaj, without using any Excel, no MATLAB, right inside. Then we have the regional, how to do it the right way and the wrong way. We look at it. And this is a software. We use software in order to get the contour map of the residual and how we're able to isolate some anomalies. Then how do we take our profile? Then you think about do modeling. Then these are some of the lineaments, the areas. This is the geological map, like I said, created by me, was adapted from the NGS. Then this is the grid that you'll be using in order to get your spectral blocks for your spectral analysis. And this is the analytical signal maps, map the contact, and so many more. Then if you check, this is the aeromagnetic data sheet. You can see that it is in high resolution. If you zoom, you will see every grade that you will be dealing with. I think our grade is 80. This is the grade we are dealing with, which is around this 80. You can see it here. When you zoom, this is the grid we are going to be using. Yeah. Then also I have some files. There is this geological map of the country where you need to have. You can see it's in PDF format. When you zoom, you see it. You can actually see them. This is the geological map of the whole of the country. From here, you can produce your geological map easily. And also you need the lineament, which show the major faults of areas of your study. And also this is in the PDF format. You can see them. These are, if you scroll down, I hope everybody's at what I'm saying. I hope everybody is hearing what I'm saying. Okay, so you see, so
Yes,
this is a,
we are with you.
so you see, so this is a major fault of your areas. How do you get this major fault and incorporate them into geological map? So this is where it is. There are two different ones, the lineament and that of the geological itself. So these two can be merged and now create your professional works. And then we have this open straight map, which will allow you to create your study area of any part of, mainly, this is for Africa. I know it's for Nigeria. You can get any country, which I will tell you later. Then there are so many other things. I've showed you the aeromagnetic and something that we are going to be doing here. So if you have anything so far to ask before we actually start the whole thing, like I said, is data analysis, because if you're able to do the analysis right, then the interpretation will be more easier. Even though it's magnetic method, it has its own shortcomings. It has its own weaknesses. Most of the time, we normally integrated it with another geophysical methods like gravity, another method like the seismic, and also remote sensing can also be incorporated. So this is what part and parcel of the income of the mineral exploration or oil exploration. Then let's move to the next slide. Then what are we going to be doing in this course of this training? Are these three things. The first is the depth or to magnetic sources, how to do it right. Then the depth to the basement, and then the edges. Like I said, the modeling is not part of this, and also that of the geothermal energy potential are not part of this training. But these are the building blocks towards those ones. That's why I start with this. These are the building blocks towards those ones. You need to know this one well before you're able to move to those other ones. So those are the things that we're going to be doing here, course of this training. We'll be able to get time to extend if possible, because we can able to do this one just a day. We need a day or two in order to be able to finish it up. Then we'll come to the list of softwares, because one software is not enough to do all these things. You need a lot of software in order to go about it. And something that you need to know about. There are many software that you need to acquire. And one of them first we start is the Oasis Montaj, which you should have. Then we have Google Art Pro, which is important to have it. You need to have ArcGIS. You need to have QGIS. You need to have software. These are the five. Of course, I have remote sensing of MV. I have MV software. I have Rockworks. All those, but those ones, the later ones. So those are the main ones. The software, the Google Art Pro, the ArcGIS, the software, and that of Oasis Montaj. Of course, you need to have Excel. As well, you need PowerPoint in order to have a touch to your images, because we can use PowerPoint as an image editor. So you need all those things in order to produce professional maps and professional grids so that you're able to present it anywhere you have. Build a confidence. So you need all this kind of software in order for you to go about your work. Then the things we look at is the initial setup and grid inspection and validation. You are given a grade. Sometimes the grade are not even named. You need to be able to inspect this grade, and also another way where you can now be able to validate on ground. What actually is it the right grade am I looking for, or is it cover my study area? And that is the important part for you to be able to know, and that is something we need to do. I think in the training, I give folders. I think I update the confirmation link. I think these are the data I gave you. I don't know whether you have this. Let me 80. Is that so? Do you have this file?
Yes,
Hello?
I think I have. I have.
Okay. I think I've shared it. If you can check back your email, I've forwarded it
Yes.
back. I've
Yes.
updated before. It was 1, 2, 3. That was it was in different area. So now you have this one that is this. So this is what you see inside. This is a spec. What I mean by expecting, you need to inspect first. This is the grid. This was a specification of where, who took this, how it was recorded. This was there inside. When you open it, you have the view of it, the company and the rest. So this is where it was, how it was collected, the sensor clearance, 5 meters and the rest. You can see them about the company, equipment, the flight line spacing, the date the data was collected, which is very good when you come to IGRF. You can see it. And the grid cells meters is 50. And then you also have this one as well as the projection, which is the UTM, Macapto. And if you scroll down, they give you a sample of the map. Of course, you can see down here, WGS UTM zone 32N. You can get this one from your country of residence, from where the grid is obtained, to know which projection that you can use for your data and the rest, and that of the date the survey was collected, and what is the height, which is around 80. You can see 80 above where the data was collected in the lines. Okay, so this is the what first you need to expect. Yeah. Then the next thing, there are some shape files which you need to have for your country. Of course, this is Nigeria, where you have the shape file, which you can get from it, which is very easy for you to get online. Of the country is easy for one to able to get. So it's not hard to get it. Those are the three. Of course, I share this one to you for you to see. Then there's some other resources online where you can see. Of course, this is the YouTube channel you are familiar with. And this is the same time is my website. As you can see, I'm the one here. I'm the one. So I do a lot of stuff. Then, like I said, this is the place where you need to get your shape files. If you want to create study area of any part of the world, you can see it's listed. So this is the address of the website, which you can see there. You have Africa, Angola, a lot of countries. You can scroll back and check back to check the details. You see, so I was in Africa. So you can go to one up level to see in other part of the world, continent. You can look at a country and decide what you need to download is the zip file or this file. The moment you download this one, the size will be there. They're huge size, but on this one, I've already downloaded it. which you can see here in the data shape files. No, it's not, no, in my resources. So you can see in my resources. So in my resources, you can see them here, which is this, which you need to have in order to be able to do your work. And then you have OpenStreetMap. This is where you see the map you're talking about. For you to get a shape file from this, you need to use this website that give you the shape file that you can able to create your study area from. This is Art Explorer. When you are doing remote sensing, this is where you get a lot of data from USSGS, which you can, this is my account, which you can create a free account. You have access to have a lot of data set, Landsat, digital elevation, a lot of them, you can able to have it. You need to have all those things ready. So now, and that is what we expect. And then the validation. To do that, we need to go to our desktop. Right on our desktop, we need to create a folder. On that folder, we create a folder, OSM training. You first have to create the folder of your work so that you can share this one to your friend to have a look at it. Then inside this folder, we move our data that we collected. I give you, bring it down into this one. We have it. Open it. Then we're going to create a series of folders here. We need to have maps. We need to also have ArcGIS project. QGIS project.
Hello, good morning, sir.
Good morning. Yes.
Sorry, please, I just want to ask,
Yeah.
will this video be recorded maybe on your YouTube page?
It's going to be recorded on the cloud, so I'll give you the link for you to download it. Then later I'll upload it to YouTube.
Okay, thank you very much.
Okay, so like I said, it's hands-on. What you normally is not for you to just watch. You can be watching, ask questions, then later you're able to do what I'm doing. And that's why I'm giving you data to see whether we're on the same page. Later you share, let's see if you have one or two difficulties in doing it. And that is the essence of the training. That's why I give data so that we can share. We have cross-validation, what goes wrong. So that is the essence of the one you need to know. Under this, actually, we have software project. We are organizing your work, then Google Art project. Then images. So other folders will come later. So this is how you organize. So all your ArcGIS work will be here. Your data collected, your Google Art, your maps, the image, QGIS software. You see, I create maps different from images. Okay, so these are the things you will have to do. So having creating this, you close. Because remember, this is Oasis Montaj. You can't do everything here. It's limited. So each work, the main work of this is to analyze. When you want to create professional map, you delegate it to that of the QGIS and ArcGIS. And that is what they meant for. When you need each, you have to contour or to create, to plot that of wireframe 3D plot, then you take it to software. Software does it better. So each one of them have their strength, and that is what you need to know. The maps created in Oasis Montaj are very poor. For you to take it further to other software, you have to move from different part to another part for you to add all in one. And that is what you should take note of, which you are going to see. Now we have created a folder. And then the next thing on the slide is, first thing is not to validate. Validate means we first need to open this one and go to the ground and see where the data is. You are given. Then now we have opened Oasis Montaj. You come down to File. The first thing you see is only these three menus, Files and Help. You come to File, Project, New. Right? So you have New Project. Go to your desktop. You see, so this is the mistake some people come when they start open Oasis Montaj, they'll just come typing the name of the project, which is wrong. You need to organize your work because you are saving it at the root of the software. scroll down to where you have the CTA, or double click, then you not put it training 1. So this is the name of the project. The extension is this, Josoft project. Then click on save. So click on save. So you see, so you can see, click on what? Click on save. So we have everything here safe. We have everything here safe. Now, the next thing we need to do is to bring our grades. Now, we will come back to this. We have a lot of stuff here going on here. We have the file menu. The most part of the file is to be saving your work, right? So after you save your work, this is your folder you have. Then when you finish all your work, you want to share it or you want to transfer it to another person, what you need to do is just have to zip it. Right click, you compress to zip, and then you share it to your friend. Once the person opens that folder, all the person needs to do is to come here, and just see if I open it. It says the training we have created. Right click and open. So everything is going to be open. All the files are going to be placed the way they are there. Of course, there's one thing I didn't create. I need to create shape files. Shape files. So I need to have shape files created. Okay. So that's what we have. Now this is our Oasis Montaj. The only thing we need about the file is our project in order to save. We don't need much of the edits. Of course, GX, these are modules that you can load in order to carry many analysis. You can see the number of menus here is limited. You can add anything you want to add by coming to load menus. You can also remove a menu. You can remove all the menus you added. These are the default ones. Edit down to L. The database, because database are the data of the grid you are going to be using. You have the new database, you have open database. Most of the time is new, use most of the time. And how do you bring import? That is to create your database. How to export your, you see, you have so many formats where to export your database, how to import, how to export. So those are the most 3 things we need to look at: new, import, and export. Also the map, where we create our map, new map, we open a map, we import, and also we export, because there is nothing to be export. That's why it's blowout. Then we have ArcGIS. You see, this is the connection between Oasis Montaj and what? ArcGIS. It allowed you to take your map from here and did it a professional work there in ArcGIS. And that is an extension. MSD is an extension of ArcGIS. So the only thing we need here is this last one that is blowout. The moment you do that, then you have made the connection to ArcGIS. You can only have this to be working provided you have ArcGIS installed. Coordinate system, of course. The wall is in the geographic coordinate system, but once you put it on a plane, it now becomes a projected coordinate system, which is XY. Now we have this 3 part. We have the set coordinate system 3. So these are the 3 things we are going to be working on that coordinates. Then we have database tools. Of course, what we are going to be doing here is more of the channel mass. It's just like Excel. Database is just like the Excel, where you can do a lot of maths there. You add a sheet, you have this database utilities. So the only thing we needed here is how to combine a lot of database grids, how we can window it, how we can do a lot of filters here. Then we have grid and image. So this is where we plot, and those are the utilities: gridding, utilities, and filters, as well as grid knitting. So you see it, those are the one: grid knitting, filters, utilities, grid masks, and those are something we need. Map tools is where you can able to edit, put a line, arrow, profile, and the rest, all thing here. We have the section tool, also allow you to take it further. Then this one is not part of it. Seeker is not part of it. Windows is not part. So Windows, you see, there's notice open. You can close all. You can open a new window. So this is what we have. Now on the left-hand side, you have so on the left-hand side, you have the database, grids, maps. So those are the three things: database, the data itself, the grids of our plot, the maps that we are going to export. Then there is ArcGIS connections. All the export you do to ArcGIS are Savior. This is, like I said, this will be another course on itself under the modeling aspect. That is GIMSIS. Gravity, magnetic, seismic. Modeling is under air. So this is what we have. Then we need to add a lot of menus. No, okay, let's come back to our grid first. Under grid, we right click. You see, when you select blue, it's highlighted, but that means you're already selecting grid. You right click, you add grids. Now you see, it's going to open straight to our folder. You go under data, you click on this, then you open it. Now this is the grid. You click on this to maximize. This is your grid. If you look down on this status bar, you can see something here. Let me see, this one is, if you look down, you see there is unknown coordinate system, unknown. It's not been projected yet. You have to tell your software which coordinate system. Hello? You can answer, yes?
Hello.
Hello, yes.
Sir, I have a question. From where did you downloaded the gridded data that you have imported Oasis Montaj software?
No. I was given the grid data was provided. Here in Nigeria, it's not free. You have to purchase it. In some part of the country, they have the website where
Okay,
you can download. Yeah, so it's going to be provided. That's why I'm provided with that of the under my resources.
Oh,
The specification is going to be
actually, sir,
provided.
I am from India, so
Yeah.
I can also purchase the data. This gridded data is available for world. I'm from India.
No, it's only for India because each country do their own survey, carry out their analysis and save it. It's only people in India will access it. If you're this, I cannot be in Nigeria able to download this except if make free of charge. But here in Nigeria, you can get this data anywhere in the world, provided you can purchase it and use it in your analysis. You can be in China, get this data and analysis. I can be in Nigeria, purchase one in India, do the analysis. So this the grid need to be sourced. That's the only thing. So that's how it is. So the grid has been taken by our magnetometer. What we have, the next thing we look, you see, it's not being projected. Then you see, how do we move about this grid? You see this, this I think this is zoom. If you click on it, it's open up a little bit to see the grid. Actually, you see, you are seeing the grid, but not full. So if you want to zoom to the grid, you can use your scroll wheel on your button. Or you can click on this, zoom in. You see, you keep on zoom. See, you are lost. If you want to bring it back to focus, you click on this, you are back. If you want to zoom out, smaller, click to the full extent. Yeah. If you want to increase pan, you see there's a symbol here. If you click on pan, you see, you drag it, nice drag. You have to click again. So another way of doing it is for you to hold down your shift key. Hold down your space bar on your keyboard. Then you now drag. You can see it? I can drag it anywhere I wanted it to drag. I can drag it and inspect the map anywhere I wanted it. Right? Where your space bar is pressed down, you are dragging. You see? So now you release the space bar. You see, then later you click back on this, you are back to this. So this is how to move your grid around, to zoom in and out to see it. So this is the grid you have, which you have already here. Make sure to be saving your work as you move forward. Now it has been saved. Now we say we need to validate this. How do we validate it? First of all, we need to get this grid to have our data. What are the data? Because sometimes you are giving grid, sometimes you are giving in form of Excel format. So we need to export this data to database to see the actual data of this one. If we want to inspect what is the value of this grid we're seeing, we come to grid and image, utilities, point values. This will tell us, click on point values. Point values, you see, you select the grid. So if you want to see what this one does, click on this question mark. In all the pop in Oasis Montaj, help. Click on help. You see it? It gives you what it does. It reports the grid value at a specific location map on your grids. You can add up to 4 grids and inspect them side by side. That is what it does. Select this arrow if it's already open. If it's not open, use the 3 dots to browse where it is. But if it's already open under grids, you can see them here. Then you select the one. You see TMI, then you click on point. You see your mouse pointer change. Click on this I value. What you see when you click, you see the value. This is the location of the point in meters. This is the actual value, which is 101.5 nanotesla. You click on point to see another point. Click on this green. It's around -16 nanotesla. Click on this blue so that you inspect the value. You see, I've already closed, that's why. So this is how to do it. How to inspect some of the values. Then we want to push it to database. All we need to do is to come back to look at our grids. You see it's being bold. That means your current grid is selected, which you can see at the title bar. You're working on this grid. You go to grid and image, utilities, save grid to database. Click on this. This will push it to the database. Now we have grid file. Look for it, or you browse for it. Then look for it. Then the database, now I'll call it the TMI, because naming is very important. TMI is this. The database channel, because remember, this data is in X, is in 3 values. The XY give you the location. The third value give you the value at that location. Here is in magnetic intensity, which you call Z. It's better to use that. All other things remain the way it is. Any values that is empty is not going to be included. That's what I mean by trim, leading, and training dummies. Leave everything as default. Click on OK. You can click on this to see the help menus where you see a lot of the stuff is there. Then from there, you click OK. Because this one is important. Everything, so this is why you start. Now you have your database. Project save in case it's safe. You see, sometimes you have something like this, shows up. What you just do is, if you say, do you want to make changes to map? Just click no. So you are still back where you are. Click on this. You see your database is selected, your grid is also open. So this is what you have. You need to have your data being included, which is this. So we need to have the database being included, which we have this one. Then the next, we have to take a look at the database very well. It is a very huge data, which you can scroll down to have where you have, because it's good for you to be able to master it very well. These are lines. On line 1, there are about how many data points were collected. 71. The flight, right-click on this, you see list. You see them? They're about the first line, I'm calling list. You see about how many lines? 554 lines. If I want to go to this, the last line, you see it? This is the data along that line. About how many of them? 151. So this is how the data is being graded. It's been flight across flight lines. So let me go back, list, go to the first one. So this one, you see this one, you see X, highlighted with blue. This shows that your horizontal axis is X. This one, Y, showing the vertical is Y. The Z tell you the third value, the value at this location. That is your Z, right? You can click on this and right click. You click edit. You can change this name to whatever you want, right? But it's better to just leave it anyway. You click, right click and right click, you edit. Same thing to this. You can drag, just like Excel. You can drag and do many things where you want to do it. You can also right click and delete, but you have to be careful not to do this, right? So now the next thing you can also add, you can right click inside, just like Excel. You can insert a column just before it. You can hide a column if you don't want to see it. So now this is the third value, and this is what we have. The next thing we need to do, we need to put this in the right coordinate system. That's why in the source folder, resources, I give you this one. Under data. If you check your data, before we start, we'll check our data. It is WGS 84 UTM zone this. Then we need to project this one there. We selected, we go to coordinate system. Now you click on the middle one, coordinate. We need to put them in the right coordinate system, the database. Then this is georeference database channels. Your horizontal, this is for you to confirm. Your horizontal is X, of course. Your vertical is Y. Okay? Then now click on coordinate system. Now you see it's showing unknown. Then click on, because this one is projected, you can see the values. These are all in meters, projected. Now you see, you leave this one, you only come here and change the location of the wall where you have it. You can write UTM, scroll down to 32N. I think where we have it, 32 down and 32 degree N. So this is where you have, you see it? It's already projected in meters. Then click OK. Now the data is being projected. So you can still confirm from your coordinate system. You see it, it's not being projected. But now what we need, this is on the projected main on the flat surface, but the art is in sphere, if in 3 dimensions. So we need to go back to our geographic. We need to create our geographic channels. We right click on the first one and put insert column. You see it, I've insert one. Click, right click, insert. So I have 2 now. The first one I will click, edit, like this. Click, right click, new. You name it long. Normally the longitude is horizontal axis. Then click the decimal point to be 3. Come to the next one, which is lat. This is our lat. And then here is going to be 3. Then now we need to project this X to longitude, the Y to latitude. How do we do that? We come to coordinate, now the third one. Now the third one is now new projected coordinate system. Now, this is to confirm your initial projection first. Confirm X, Y, okay. It's still to confirmation. Notice change, it's already meter, then now finally, okay, it will now ask you to create a new. We'll change X to longitude and the Y to latitude. Click next, then now it's going to ask you to select. We'll now choose geographic. You see, it is already in degree. Okay, just click OK. Now wait for, so now you see it has been open. You see this 2 dot means it's not enough. You extend, you click and drag. But you see the format is not the what we want it to. Click, right click and change the format. In geographic to normal, 3 decimal place. Now you can see it in degrees. You see it now? Click, right click, edit. We change the geographic to normal, then 3 places of decimal. Now we have everything. So this is your database of all the TMI you are going to be using. With this database, you can do a lot of stuff with this. Now, I want to switch because I'm going to plot the grid in order for me to what? Do a validation. It is important to cross-check to see really on ground where this data was collected. This is what we have. So I need to switch X to longitude. How do I do it? I go to coordinate, set current coordinates. So it's for you to switch. I want to switch the X to longitude, the horizontal, the vertical to latitude. Then the Z is already the one that remains, and click OK. You can see them now. You can see now it here. Highlighted blue. That means horizontal this. Finally, I can now grade an image grading. This will now allow you to grade. Grading minimum curvature so that you can grade it very well. Under this one, channel is just like the name of the column. Which column do you want to plot for against? Z. The output grid. Yeah, like I said, you need to name your grid now, TMI, but this is underscore lat long. So this is how to name your file. If your grid is in projected XY, name it XY at the end. If it's lat long, put LL so that it's easy for you to identify. Then grid size, leave this one empty. Don't do anything here because this one is not in meters. It's geographic. When you do meters, it's important when you come to Euler deconvolution. That is when you need to use the XY. But for here, that's why we are doing lat long always leave the grid cell size empty. Then just click on OK. Then our grid is now going to be produced. Nice. This is the grid, right? Which we have. Click on this. You see now, if you scroll down, you can see WGS 84. It's now in geographic. Now, our former grid, we right click, want to remove it. We have to clean up. Right click, click first. If you double click, you end up changing the name. Just click once, right click. You have a lot of properties, metadata, and the rest, which you will see later. Then you have, if you click delete, you are deleting from your folder completely. Don't do this one. Always remove from the project. That means while this one is open, but it's still there in your folder, click on remove. So now I've cleaned it up. So anytime I open the project, it's only this one I'm going to be seeing. So next, so I have only one. The next thing now to do is to validate. This now is geographic. How do we validate? One first to do is to export this one. You see there's something you see here, which is called, if you scroll with your mouse, click on this, look like this, click on it. The arrow will change. You see it has changed. Just click on your grid. It has put it in a map mode where you are able to export. You see, you click on this, it has exported. Go to map. Click on export. Click on export. Right? When you click on export, you will see something like this will happen. This gives you different format. Now you scroll down to the last one, which is called the QO markup language, which is the Google Art format to see it on Google Art. QO markup. You see, you do all the settings. You don't need to do anything. Just click OK. QO markup, the last option down there. Then click OK. Then now, this is from Google Art, so you now put it inside Google Art. Right? Save site, or then call it TMI. Then click Save. Now you see we have saved it. Then click outside. Click Project. Then Save. Now minimize. Go to your folder. Go to your folder of our work. Go to data. Go to our what? Google Art. You see it? This is a Google Art. You see the format? This is Google Art. You see the symbol. Then right-click, Open. When you click on Open, it's going to take you to Google Art. You see it's in Nigeria. You see it has passed Nigeria. This is where the grid was taken. So I hope you are seeing it, right? Hello? So I hope everybody is seeing this one, right?
Yes, please.
Okay,
Well
so
understood.
so now this what you have this. If you're in India or anywhere of the world, you have to know, okay, I'm looking for this grid that cover this area. Kiro, okay, it's covered, the grid is okay. I validate it, I can zoom out. Don't use your mouse scroll wheel down to scroll down. You see it? This is in Nigeria. You can get, you see that? This is Nigeria, which is the shape of Nigeria. You can get through with this one, borders, places, and roads. See it? So now this is Nigeria. So this was where it was taken. That grid, it was taken. This is where it is. You can bring them back here. You see roads, you see places. So this is what you have here. If you scroll, this is what you see in Google Art. You can pan, you can click and drag. You can zoom out this, what you have. You can zoom out and see what you have. Okay, this is my grid. It has covered the area where you want to have. So this was actually, see, this was actually a pond, maybe a dam. This was a dam. And hydroelectric powered dam is here around this area. So this is how it was taken. You see, so this was the grid that how to validate it. You are not check your towns are here, which is very important. So this is how to validate. Okay. So this is Google Art. We are coming back to it. To get those towns, you see how to create a professional map. So here you can untick this one. So you see, you cannot zoom in and see the area in details. But you need a fast connection. You see, railway. This is a railway. You see a railway here. So this is a very long railway. So this you can take it back. You have, right? Okay, now let's minimize. We are now able to what? Validate. The validation is okay. Your grid is in the right format. You have seen it on ground. Your projection is okay. Now the next thing we do is to creating professional grid maps. How do we create professional grade maps? Because you need to have maps. Whatever analysis you are going to do, yeah, you end up going to have to present it in your work. And that's what map come at the last. So for you to be able to create the professional maps, then that will not be very thing we're going to see. Sorry, okay. So I'm back. Okay. So let's see what we're going to create. Now, to create maps, any of this analysis we are going to do, the end result is to present it, is to what? Is to change it so that you now have it in the form of something that you're able to present in your work like this. To have something like this, you can put to your work like this. That's what I mean by map, professional maps. And what we are going to create here actually is these professional maps that I give. You can see this TMI, very professional. You see it? Done through ArcGIS. How do you do it? Now we go back to our QGIS. Can be any of the map. So whether I do analytical any of the map, you can do the same process. This one is generally to plot a map of all the towns. Now we have this the grid selected. We don't need to do simple steps. Go to your map, the new map. Make sure that your map is selected. The grid is selected here. Click map, new map. The dialog box will open. Don't click on X. Before you do that, you need to click on scan grid. To select the grid, scan grid. And under this, what you have, you're now going to select it. This three dot to browse if it's not open. Since it's open, you just scroll, you see it one. You double cross check, TMILL, click OK. The next thing is to click on next. Before next, don't do the mistake and click finish and give it a name. You have to scale it. Click, you see, there's a scale, map scale is not given. When you click on this, it has done the scaling. Then now you name it. How do you name it? Very important, TMI. That's all. Then you click on finish, then everything is done. You have a canvas. Now where you go to draw the layout of the map, you go to, after you have, go to map tools, base map. Then under draw base map. Under this, we're going to have right size, make it 5. The left margin, make it 2, so that you have more space for your legend where you are going to be using it. Somebody said, hello, can you repeat the last stage of overlapping grid image and geological map? Why is just overlapping them is simple. You just go to the folder where we created it. So this is the one where I save it. All I do is just click, right click, open. When you do that, you are going to be taken down to this, which you can drag, you zoom, and look at your map. So this is how to overlay it. Simple. It's just for you to export the map. What I did, I go to map, export, change the format, and which, like I said, is going to be recorded. You can check it there and see it. So let's move forward. Then we'll click, leave everything, just change this one 5, the left 2. So you have enough space, then click next. This one will show up. Now this is lat long. Solid line, we don't want any cross, we need 8 ticks. The compass direction, positive X, east. Because you know the longitude is in east and west. The east is, we take it the plus. The west is the minus. That's what I mean by east. Positive is east. So that we're able to have that annotation on the something. Then the next thing, H ticks, positive X, then click next. Then what do you see? The title of the map. TMI map. Don't worry, we're going to change this one. It does not matter, just change the TMI map. Finish. Now this is the canvas from where we're going to draw the map. Go to map tools, grid and image display, and you have single grid. On this one, you have a lot of options. Grid name, you first have to browse. Cross-check is TMI. So your TMI, then you click on current map. But you have another option, apply shadow to make it more thick. Let me first click on this current map. You see your map comes in, all right? Then if you want to say, I don't want this one, I want to change it. You click on this one, map grid map, then click on the map, press your delete button on your keyboard. It has gone, click outside, then change it to this. Then go now to your map tools again, grid and image, single grid. Then now let's do something here. Apply shadow. You can click on this more to shadow effect. You can play with this one and the rest, change it, but leave the default, click on minus, then click on current. So how do you see this one? So which one do you prefer? Do you prefer this one or the other one? Hello?
I prefer the one with the shadow.
Okay, so you see, so the choice is yours. You can decide either this or go back. So any of them is going to work. So let me just press the delete button, click outside, then click on this, then go back to map tools, grid image, single grid. Then off this one, then press the current map. Now it's there. So we need to bring our legend bar. Map tools again, grid and image display. Not this one. This is different. Map tools, grid and image display, colored legend bar. Then you have this to show up. This is the title. The title of this is Nano Tesla. Click on this to change the number of decimal places. You see it? You can change the size of the text, size. Here you play with it. We click on this more or less. The decimal place, you can change it to 2 if you want. Less. Then you can put your scale bar horizontal or vertical. But let's leave vertical, then click on locate first. Then click down towards the map and click. It has given the location of where you want, then click OK. Now it is where you are. So if you want to position it to resize this, you click on this, then click on this. Then now you now move it. You drag. You can resize it. Click outside. Now you see file, project, save. Now you see everything has saved. Now the next thing, you see the map here, you see, like we can zoom out. You see, it's not that much beautiful compared to what you will see when you do it in ArcGIS. Right? So if you want to export this map, the simple thing, does in this, we're going to see it and compare the one we see. Go to map. Go to still that export. That person that has a question, how do you change it to this? Go to export now. Your map is selected. Now, instead of this, you change it to JPEG. JPEG high quality. When you do that, then this is what you have. Then you click on OK. Then you put it under images. You see it? Save it under images. Then call it TMI Oasis Montaj. That is, we do it in Oasis Montaj. Let's see the difference. Click save. So you see, you have your save. So the area is safe. So this is how you have the area is safe. Then this is what you have. Then if you go to our folder, let's open it.
Sorry, excuse me, please.
Yeah.
There was a time I was playing around with Oasis Montaj, and I noticed that
Yeah.
the scale on Oasis Montaj is kind of like I don't even know how I was able to do it. I was able to export the map to ArcGIS. So I noticed that the scale that Oasis Montaj gives seemed to be, should I say, wrong? I don't know. What is your take on that?
I'm coming back to that. Okay, now to move now to ArcGIS now. And
Okay, sir.
we're not yet get to that yet. We're not yet get to that yet. I just want
Okay,
to do
sir.
it first.
Okay,
And this, you have many options to do. You can, if you
okay,
have the
sir.
ArcGIS, you can see put QGIS, and there's a way how
Okay,
to
sir.
go about it. There's a way
Okay, sir.
of doing the same thing. Then now it's just
Okay,
about
sir.
choice. Let me right click here, view extra large. Click on this. You see the map, how the map is? It's not that much small resolution. You see when you start to zoom out, you see it? It's blue out. So you see, so this is one of the problems. And the texts are very, very small to reduce this to position it, to put this in the minute and the rest. It does not look, because that is not what it meant for. That's why it gives you option to take it to other part that will now add touch to it. And that's why we come here. Okay, I'm sorry, not this one. Let's go back. What is it? Yes. Yes. You can ask that question. You can ask. You said? What you said? Oh, you see, okay. Somebody's talking. Who is talking? I don't know. Somebody's talking. Hello? Hello? Okay, so are we set? So are we set? Hello? Are we all set? So please, so it's very good for you to just text. Please, just text it, please. Just text it. So please, if you want to talk, just try to. So now, are we there? Hello, everyone? Hello?
Yes, we are.
Okay, fine, you are there. Okay, now, you see, the map is not good because it's not what it's meant for. You see, the map is selected. You see it here? Go to this ArcGIS MSD, scroll to down. You have save current map as MSD. You just wait for some few seconds, something will pop up. A save box will appear. You need to have ArcGIS 9.2 and above. Click on these three dots. Don't just press OK because you might not know where you save it. Click on these three dots and then scroll down. That's why I created folder maps. Now, finally, it has picked up the map. Then click save. You wait, you click OK. Then you wait for some few seconds. So it's going to produce it inside ArcGIS. So somebody's asking, are you going to get all these softwares? So they are there. Maybe later I will give you some links where you can download them. Okay. Now, you see, this is in ArcGIS inside, but you see, it's just like ArcGIS. They just look alike, but you see them, the menu bars, they're similar. This one is provided, but it's not what it's meant for. So it has a lot of limitation here. You can see them, they look like this. So all we need to, this is what we have. So we don't need to use that. It has already created it. All we need to do is to come to Windows, close all. Window, close all. Just place all, save all the option. Now it has closed it. Now let's open back our grid. So this is our grid we have. Our map is here. You see, we click now, you see the map we created is here. If we click on it, we open our map, which is this. Now we minimize, we go back to ArcGIS. Your ArcGIS is open. So you see your ArcGIS is open. So you see this site you are using actually sometimes have some viruses. So it's not advisable to go to this, download those ones. So I'll give you a very safe link where you'll be able to go and download them without those having virus. So you have to take note. So I'm not infecting your system, your PC. So now let me minimize. Let's go to, after I open ArcGIS, it's not a layers, but rather it's a project. Click on file, you open. File is open. Then you scroll to a folder where your main work is. Then you go to maps. When you click on maps, you see it has picked it up. You can open this, you can drag it. You can see it's ArcGIS map document. Click on it, then click open. So there is no error doing this thing. So it has already merged them together, create many layers. So the version of the software I'm using is 8.4, right? It's ArcGIS 8.4. No, so you see, so this is what you have. You see, it has already created in what? You can see it here down. So this is ArcGIS. There's a lot of stuff here that you don't need to know all. It's only your own part as a geoscience or geologist or civil engineers or physics that you need what you need to know about this one. All you need to do, this is the map that we have from ArcGIS, from Oasis Montaj to this. Now, what we need to do, of course, there is no towns. If you can check the one I did here, these are towns, right? You can see these are towns that we are going to get, right? To bring this to our map and see how it does. So, finally this. So we're going to do that. Now we have left Oasis Montaj. Let's go to this. What you do, first of all, this is this data. Then you click on this. Let me see layers, our layers. Okay, so this is our layers data now. You see them here? We have this. If you off this one, you see this is the data. The coordinate are this. So this is the coordinate. If you click on this, you see you can delete this one. You can delete this one. If you click on this, you just press the delete button. We don't need this arrow. It's not nice. We don't need this one. You press and press delete. You click on this and press delete. We don't need it. This one, we can size it later. See, you can size any way you want it, but you cannot edit it here. Okay, so you can move it down by holding the shift key and press the arrow button on your keyboard. Then the next thing to get away with this one, how do you do? You click on it. So when you click on it, go to this one, fixed zoom in. Click on it. You see it has disappeared, right? Now, since it has disappeared, before it's like this, let's go back to our QGIS. Go to the map. I want us to zoom very well. Zoom out. Let's zoom out very well. I want you to look at let me zoom out so that we now look at the ranges. You see the ranges on the longitude is 8, 8.1, 8.2, 8.3, 8.4. So that means the difference is what? 0.1 degree. The same thing here, 11.5, 11. So we need to convert. Let's convert calculator. That is 0.1. When I say 0.1 times 60 to convert to minutes, you can see 6 minutes, right? So that's how you get the interval. Then you come back to this. After you select this one, you press this one. To get away, then you right click on this dot, click on properties. So after properties, you go to coordinate, grids. Just go to grids. So just go to grids. So just go to grids. After you go to grids, then press new grids. Make sure it's you're under grids. Press new grids. So press new grids. So now you see you are seeing new grids. So after you press new grids, you just click all next till you finish. Then you go back here under properties. So you go back under properties, right? Go back under properties. It's only 3 tabs you had. First of all, the label. You select the font size to be 12. You want the vertical to be aligned left, the right, vertical right to be this. Tick these 2 always under label. Go to lines. Do not show those lines or ticks on the map. Then go to interval. That one you use in our calculator, which is 6 minutes. We have only degree and minute. You see, we need degree and decimal minute. The interval, we put 6 because it's 6 minute interval. The degree is 0. This is the interval. Put 6. How do you get 6? The difference is 0.2. Convert 0.1 and 0.1 to minute. That is 0.1 times 6. That will give you 6 minutes. And finally, you click apply. You place OK. Then you now click another apply again. Then OK. I'm sorry, click on OK. You are good to go. Now you see it? Let's bring it well aligned. Just click and drag. Move it down like this. So it's like it's okay. Move this one. Click drag. Resize it. Then move it to the right like this. It's okay. You see it? Now the next thing to do is to bring our legends. We see here. Those our knots and the arrow right title like this. How do you do it? It's simple. You go to insert. First go to knot arrow. This is a knot arrow. You select it. You can browse. There are many of the knot arrow here. You can check. Click OK. You see it's there. Just drag it, position somewhere here. Like this. So this is what you have. The next thing is to bring the scale bar. How do you bring the scale bar? The scale bar is something simple. Come to the scale bar. Under here, we'll click on this. There will scroll. You see, I've already created one scale bar I'll be using, but you can have your own save you want. I need this format. You click on this, go to properties, so that you change it from miles to kilometers. Then you have pop-up will show up under the divisions. You can see it's in kilometers. The label, you can call it M. Then click apply. Then OK. Then OK. Then I move it down. Yeah. You size it down the way you want it. Let me see. This one is taking up my space. So now, so this is what we have. So we have this one. It has been arranged. You can put your shift band, position it well. Then now we need to bring the text inside text. So this is how we are going to do for all of your map. You see the text is there. Just click. Then click. Just drag it. Then now double click on it. Then now total magnetic intensity map. Then click on change symbol. Change it to around maybe like 15. Make it bold. Okay. Then apply it. Okay. Now you can see it here. So we have it ready. So this is what we have. So if you just want to see a preview of it, if you want to save it first, before bringing those towns, where do I get all these things on your map? Because if you leave it like this, it's not professional. Because we don't know which towns are here. Then let's first export this one first as image. Under file, export map. So under export map, you wait for some few seconds. The next thing will happen is go to a desktop, go to your folder, always. Then go to images. Then now TMI ArcGIS. ArcGIS 1. Because I've not put towns on them. Let's save. You see this one, the resolution, you see it? It's 450. The clarity of it, if you increase one to 500, the file size will increase. The more you increase, the more it becomes more, the more you zoom out. The resolution is too high. So just leave it at 450. Click save. So you see, it's now actually saving them. Wait first. Now it's safe. Then then minimize. Go to our folder. You can see it here. Compare this. This was what we have before. Right? This was our what? Oasis Montaj one. Now let's go to ArcGIS 1. What do you see? Do you see it? You see the difference, right? So this is how to create professional map. Of course, it's been saved. You see them? So this is how the map is. So I hope everybody is following, right?
Yes, sir.
Okay, now the
Yes,
next
sir.
thing. The next thing now, we need to get what? We need to get those towns, right? We need to get those towns. You see them? That person was saying that the coordinate, the scaling. You see, the scaling is correct. It's not that maybe, I don't know how you do analysis. You see, if you look at the ArcGIS, you see 8 at the border, 8.5 at this. The same thing you have in ArcGIS. They are in line. You see them? Because the same, nothing has changed. So it's wrong. So that's why you need to take
No, I
time
was
to do it.
referring to the scale bar.
Scale bar? No, okay, what I mean, the scale bar is different from what you have there. So this is one of the scale bar you need to apply. It's more better. Because Aeromagnetic Montaj is not good in that one. Already it has given you your map, which you export. Because that's what you have here. So this is a scale bar you need to use here. So use that one of ArcGIS. It's more better. Now, how do you bring those towns? We go back, right? I think we have opened our Google Earth. You can remember, I think we are right? We are here before. So it was like this. Now, I think let me delete this one first. No. Now let me go back to my training. So if I go to my training under Google Art Pro, you see I have this one, right? I will right click, open it. I want to get those towns. I need to get my towns. You see them? Fine. So it's very, very simple. You see the towns. You see those towns you see on that map. Let me show you what I did on that map. You see those ones? You see them here? How do I bring all those ones you see on the map? It is from here you do it. Very simple. You see that town? You see Kiro? You see them here? It's like this. The more you zoom out, the more you see more towns. But leave it the way it is. If you go further, if you zoom out, you see the towns are increasing. If you go down, they increase. They are too much. So just come down a little bit. If you are satisfied, like this, I'm satisfied with this one. Let's say this one. So I think let me just, okay. Let me zoom out first. So let's zoom out first. Okay, now like this. You see them like this? So now it's okay like this. You have how many towns? 1, 2, 3, 4. You see them? So how do you put those towns on the map? It's very simple. Then come here. This is on the left-hand side. This is my places. Everything is here. My place, temporary places. Under my places, you click on it, right-click, you add a folder. Then your folder, you call it the towns. This will not be your towns. Call it towns. These are your towns. When you click the towns, you right-click on that towns. Remember, click on the towns. Click on the towns, then you right-click, add placement. That is location. Click on placement, place mark. This one will show you. See, something will blink it. Now, I want to name this place. Let's say I want to zoom back further. I'm coming first. Let me cancel this one. Let me go back to where I was. Okay, like this. So now I'm seeing those parts. So now let me go back, right-click, add place mark. Then I want to name this part. Rantan. You can look at the spelling. Rantan. Don't those you see, move your mouth now, drag this point. Move it down to that name. The name disappear. You see, it has not disappeared. You see, it has disappeared. Maybe somewhere here. Because it's very close to the edge. You can leave it there. It's okay. Then you click OK. Now you see the place. There, I need this Kiru. To get Kiru, go back to your towns. Click on towns, right-click, place mark. I'll now press Kiru. You move this one around, then bring this one, drag it to Kiru till the name disappear. See, this is Kiru, place OK. You see, it's not properly placed. How do you place it? Go back to that Kiru, right-click, properties. Then now, move this one by the side. Then drag this, and then position it anywhere you want it. So now it has position. Let me just do 3. Let me take this BBG. So I will stop from there. So this is how you can go on and do. BBG. So you see, where is it? Move this to the right. Move it here where it is. That disappear. Now you see, so I have 3 towns, all right? So this one is enough. You can go and do the other ones if you like. Do the same thing to this point and the rest. So that's how to go about getting those towns. Now the next thing is to export this one. You see, it's under towns. I have these 2 places. This, which I can hide this and this. Then under this 3 towns I have. Then right click on the towns. You see what save places are. Then you go back to your folder, your desktop, where you have your work. USM training. So you have USM training is there. From there, what are you going to do? So from there, what are you going to do from here? You see, from here, you are going to actually go to this place, Google Earth again. Now, you see, you leave it at what? Towns. Just leave it at towns. Okay? Click save. Now it has been saved. Okay? Then you are now free to minimize this one. Then we go to QGIS. Like I said, we have a lot of software we're going to use now. So we now go to QGIS. We bring back those towns here. We go to QGIS. Go to layer. Just go. Don't forget about all these things. Just go to layer. And this point, layer database management source. The file is vector. Then click on these three dots to browse it. Go to your folder where you have it. Google Add project. See the towns. Select towns. Click open. Then click add. Then close. You see them? These are the towns. Those are the towns we see we have put. Then the next thing is to export this one to shapefile that we can now use in ArcGIS. Go back to click on this question mark. You see, you have checked the coordinate system in, which is this, but you can still leave it. There's no point there. If you want, you can just forget about it. Then just right click, go to export, save feature as. You see it? Click on this. Then you see it's in a shapefile format. Then click on this three dot to locate it. Go to your desktop, go to Oasis Montaj training, go to shapefiles, right? Then later you now call it towns. You see it? So this is your towns. Then click save. Okay, so this is what you have saved. Click everything. Add, you say untick this one because we don't want to show it here. Just click untick this one, then click OK. Wait for it. You see it's loading. It's not yet finished. It has finished. All you need to do is to close the Google Earth. We don't need it again. Don't discard. We are done with the towns. So we can use this town in any of our maps. So let's go back to QGIS. You have done it. You only do this only once. You have done. Then go to ArcGIS. Click on this add data. Click on this arrow, add data. When add data open, you have to go to this connect to folder. Click on connect to folder. Scroll to the main project. You see it? Select the folder. You're going to choose a folder. Just select the folder, only the folder of our training. Click OK. Now you see it has opened our folder. Where do we save it? Under shapefiles. You see the towns? It has come. Click on the towns, add. The town is there, but it's not visible because it's under. So you have to drag it up. Drag it up. You see the towns here? These are the towns. So this color you see, they are black. I can change it by clicking on this, double click on this. Change this black, reduce the size, let's say to 15. You can change the color if you wish. Increase the size. Check any of the symbol here, click OK. You see them here? You can double click again, reduce the size, maybe to around 10. It's too big. Now you have it, right? Then how do I put those names there? Then you double click now on the names. Double click on the names. Now you go to what? Labels. You see labels? Click on labels. Then label features on this layer. Then you select the size as 12. Then you bold it. Then you click apply. Just select the size. Tick this one. Select the size, bold, apply. Okay. So now do you see them here? Are you seeing them? Hello? Hello?
Yes,
So
please.
so now everything is now okay. What we are seeing. So we are seeing it them here the way it's supposed to be. So we have everything. Now the next thing to do is to format this one in a beautiful way, like this, right? How do I do it? Let me change the symbol now to triangle. I've changed to triangle. Now, let's go back to towns. Double click on towns. So we now take it further. So now refine it. Drag this to this side. Then click on this symbol. Click on symbol. Right? Select any of this. Let me this one. You don't forget about it. Don't select it. Go to edit symbol. Go to edit symbol. Then under edit symbol, leave everything here. Go to formatted text, advanced text, text background. You see it? Text background, properties. There you put symbol. There you put the fill color, you put it white. The outline color, you put it white. Right? So this is what you do. You put it okay. You can see how the name will look like. Then this top size, you can bring it down to 1. You just be looking at this. You bring them down to 1. Bring this one to 1. The right side, bring them down to 2. Bring down to 2. I think it's okay. Now, if it is okay, so we have this one like this. Okay, formatted text, okay. Under text background, the general is this. Then if you like, again, under formatted advanced text properties, you can, no, it's not properties. Let me go. I think under marks, no, it's not marks. Let's see whether shadow, we can put shadow symbol. No, okay, we'll just leave it like this. This is okay. Just click okay, then place okay. Then click apply. So now, are you seeing it now? I hope everybody's seeing it.
Yes,
right?
I see.
So now from there, you save. Then go export now. Map. No, not now. Oh, I'm sorry. Legend. I've not put a legend. This one to show the towns. That legend. Go back to insert legend. It's only towns. Just place next, up to finish. Then drag it. Position it here. Double click on it. Go to this symbol. Change the font size to be 12. Okay. Apply. Okay. Position it. Then down the way you want it. You are good to go. Then save. Finally, export map. So you see, finally, we now export the map. So now this is our final TMI now. So this is how you produce all the map. The map will come at the end of your analysis. After your analysis, you will sit creating all those maps. All those your towns are already there. You just be open them, be putting them on this, follow the same format. But we don't need to create the towns again. How do we view it? We'll go back to our this images. Now is the TMI. Now you see it? This is excellent. So this is how you put towns on your map. So you see, if you zoom out, you can see them. So this was the map we have from Google Earth down to this. So do you have any questions? Let's see. Do you have any questions on how to produce map?
Yes.
We have seen how to produce map. Yeah.
Hello?
Do you have question? Let's see.
Yes.
Yeah.
Yes.
Yeah, you can ask question. Go ahead.
Why we change into GIS?
What? Why we change it to GIS? ArcGIS? Hello? What are you saying?
Do you hear me?
Yeah, yes. What are you saying? You say what?
Why not we complete by using only Oasis Montaj?
Why do we use what?
Why do we use only Oasis Montaj?
Well, of course, there is no one that is being available because all those things, if you look at the data, let me go to the data. This is the data.
Yes.
It's a huge data. If you export this data to Excel, of course, we know if we talk like the vertical, like Excel, we can still plot a map, right? What you are seeing, this one is just a map. It's just an ordinary map. It's just like plotting Excel. I think when you open Excel, under insert, I think we have this one, maps, right? You can have inside all these 3D, double 3D software that can able to plot those ones. You can able to plot them. But the data here is huge. You see, which later I will show you when you export this one to Excel, you want to plot it here. Then the Excel will end up crashing. It's a huge data. So that's why it's not easy to be done there. That's why this one is dedicated for that purpose. In MATLAB, you have to write a code because this is the point. This is the value. You can do what they call numerical differentiation, just like your vertical derivative. How you get the derivative of the grid along X, along Y, the vertical one, which you use the Laplace equation in order to arrive at that one. It can be done, but the Excel cannot handle it. And the only available one here is this. You can also use that of software to do that. But the one that is best for that is Oasis Montaj. That is what it means for. Can handle that issues compared to Excel, because I think that the data is just from here to here. It's only this point. There's no need to even use this. You can use our Excel and use those equations and do it. That's why it's only Oasis Montaj we have to use. There's no way around it. That's been there for a long period of time, just like ArcGIS and QGIS. So for you to have another one to come back and overtake them, it will take time because they're meant for that purpose. Just like Excel. Why have we used Excel? Why can't another thing? Excel has been there for a long period of time that established itself. So that except somebody will come one day and start writing a program that will process this. But in life, what you have to look at is don't repeat yourself. If something has been done, don't try to reinvent the wheel. Don't try to reinvent the wheel. Something's already there. You want to bring something. You end up doing the same thing with what they will do because it's the same algorithm that is being applied. That's why we normally use Oasis Montaj. So I hope I answer your question.
Okay, thank you for your
So
nice.
that is the idea. So now, so this is what we have. I think where are we? I think this was what we have. We're able to create maps, right? Now we're able to create maps. So this you do this one for all of your work. You see it one for analytical signal, spectral block. Now this one regional, which you are going to see shortly. Regional and residual. How to separate them. Now you can use. You see all these are the maps. You can do the same thing for all those maps. You create them, you export them, you do your retouch. This one showed us how to create any map in this professionally. And remember, it is safe. Whatever you do here is safe to this. So this, you can still come and do another one and still edit it, what is there. So that is how it is like that. And that is how to work with it. So we don't want, you can click on this three and delete it. So you see, we have now deleted those ones. We don't need them again. Then we can go back to our, yes, now let's export this data. We actually need to export those data before we not try to do those kind of work. We have validate, we have plot map. Now the next thing we need to look at is how to export this to Excel. Why do you need to Excel? If you look at your work, we need to isolate anomalies. Look at this one I've done. You see this one? It is a very tricky way of doing it. It's not direct. You see it? So this is also a residual of what you have. Or you can do this one for any of the map that you want to do. You can do it any of the map that you want to do. So we'll see how to go about that one. But let's see how to export database to Excel. That is the first thing. Before you export, you want to export only lat long. Remember, when you are doing calculation, you need to put them in X and Y. When you are plotting map, you put them in lat long. Don't try to make that mistake. Calculation are done in the projected coordinate system, not in the geographic coordinate system. Take note of that. Now, if I'm exporting this, in order to plot them in another, to use another analysis, I may go with this or anywhere. How do I export? Go to database. See, go to database, look under what? Export. export to CSV. So just click on export to, just click on export to CSV, right? Then from there, you enter the file name. So what is the file name? Let's click on this three dots. First, to be confirmed where you want to put it. Put it under data. Then you call it TMI data. Right? In CSV, it's already in, now you click on save. That is Excel format separated value. Then these two things are important. Under this, somebody asking a message. Okay, no problem. I'll try to send it later. Channels to save. We'll select from the list. Line group, all the lines, all these lines. We want to select them. All the lines, we need all the data, not only this line, right? We need all lines. Let's sign up. These two things must be changed like this. The other one will remain like the way it is. Don't include any empty values, right? Include the channel names. That is it. Then click OK. Then now this dialog box will open to show us what do you want to select, what do you want to move with. So you need to select them in order. First, we need longitude. First, we'll go first. For the horizontal. For the vertical, I need latitude to go next. Then the value, which is Z, to go next. So I don't need this one. I'll click OK. Now you see, it has been saved, but it's not yet open. Let's go to our folder under data. This is the data. Double click on it. If I see what is the size? I'm coming first. You see, it is 15 MB. You see, it's 15 megabyte, while the grid is 1 megabyte. You see the difference between the two. That's a 15 megabyte data to be analyzed in Excel. It's not a small something. We end up crashing the Excel. But look at this data we have. You see it? It's that long. You see the values now? No. Let's scroll to down. How many value do we have? The data. You see them? How many? We have about 301,279 values we are taking in this grid, in this study area. It is a very huge data. Look at the line number, very huge data. So if you end up going to plot something here, it's not going to be easy. It's a huge data. So you can use data for any purpose you want to look at them. So we have saved it. Then this is how to export what? Data. That is how to export, right? Then how do we bring this back? Somebody may ask me again, now I have my data like this. So sometimes, let me go back. Sometimes you are giving this as your data instead of this one. This is the grid. Or somebody give it, this is my data. How do you bring it back to your grid? It's very simple. We'll just go back to our place. Under database, we'll say new, all right? New, we'll not just call it new TMI. Want to see the same grid we're going to produce two different ways. If you are given an Excel format, so this is how the format is normally be given. They either give you this format CSV or in grid format. How do you bring them back? You first create a database, new, leave everything the way it is, new TMI, click OK. Now you see you have the empty database. Then go to database, now import ASCII. Then this will open up these three dots, you browse for the folder. Go to our data, you see it, TMI data, click open. Then you click on wizard. You see, it has already said them, longitude first, latitude first, Z. That's why it's good to know the way you export them. This is what you have. Then just click next up to finish. No. Then on this current map, you say yes. Now, do you see it? So this is the data you have, right? That longitude, latitude. Then now the same thing you see, it's not yet even set. We have to go and set where is our longitude, latitude. We'll go back to our coordinate, set coordinate. Now our longitude, our horizontal is longitude, our vertical is latitude. Then click OK. Now you see we have set them. The next thing we need to set the coordinates. coordinate system, which is geographic. Now it's geographic, call it geographic, then click OK. Now we have this, you see it? And finally, we can now grid it. Grid this one, this column, then we delete this one. We say new TMI. Leave the grid side. You don't have any grid side, then click OK. Now you see it has finished. You see them? I have the two grid. Now let me close all of them. Let me close the window. Save all. Now let me open these two. Let me double click on this again. Let me click on double click on this. So now you see I have two ones open. I'll go to window, tile vertically. You can see tile vertically. What do you see? You click on this first one. I'm sorry. Go to Windows, tile vertically. Click on this first one. Click on this. Change extent. Click back on it. Click on this one. Now you see them? They're exactly the same. So this is how to grade data from any of the source you have. So that is the same. Now we'll close this one. We'll close this one. Now I don't need this one. How do I delete it? Right click, delete. Finally, it has gone. Click, right click, delete. I don't need it. And I can now save it in my project, then save. This is my database, right? This is my TMI. So this is what we have in our analysis. So this is what we have. We need to try to know about how to try to do it. Now, the other part we said in the course, which is depth determination, as well as depth basement. All we need first to do is to get the regional, this is our regional map, right? This is our regional map. This is the TMI. How do you do this separation? Because it's when you do the residual, then all the other things will now be straightforward. It's those the analysis we are going to be doing. But we have seen how to create map. We have seen how to export, import, export, import. Then finally, we'll now be able to see how to create this one. How to create this one. How to create this residual. This contour, right? So that you can now be able to use them further and for your analysis to get all this SPI and the rest. All of them come from the residual because that is the most important something we need to do in our analysis. This is our TMI. It's lat long, which we do not need. Again, now we right click, remove. We'll go back to this. Now we need to do regional and residual. We need now to swap, to switch. Go to coordinate, set coordinate. Now this will be X, this will be Y. Then okay, so we are here to go. Now I don't need this one, and I can hide. Right click, hide column. Right click, hide column. Right? Oh, it has gone display on. They have come back, right? Only this one. So this is how to hide and the rest. Now this is what you have. You can just do like this. You go. You have item. And now we need to now get our regional receiver. Before to do that, we need to go back to this extension load menu. We scroll. These are all the extensions you can do for this. A lot of them. We need to look for mag map. This is the one. Select it. When you select it, it is going to show up here. Click open. You see this is mag map. So we need this one. Also in our work. So most of the time, what we normally do is to take this because the problem of magnetic data is two. One, gravity is easier to analyze because the direction, another thing is not concerned because it's all about gravitational force. But magnetic, it has two main problems. One is the orientation of the magnetic field, the time the data was collected, was not come along with the data. Secondly, for magnetic source are always dipole. They are not monopole. It's not like you can have a gravity, you can have a single mass, this and this. So they are always, it's just like electrical charges. You can have separate plus, positive charge, and separate negative. But the magnetic, they are together. They are always dipole. When you have a north pole, there's always a south pole. Because of that nature, it's not easy task to be done. The direction where it was taken at that time, the magnetic field, because it is a vector quantity, as well as this. So to put it to a particular direction that we know of, that's what I mean by reduced to the pole or reduced to the equator. So that we put at the equator or the pole, we know that it's going to be vertical. Based on that, then the work will now become to continue. So that's why it's good first to push your TMI to reduce to the equator before you do the separation, so that you take care of that one. Otherwise, you will not be able to have that correlation between your result. And that's why you have to think about it, because your regional has to correlate warp with upward continuation, which you are going to see. First of all, we need to move this one to what? Reduce to the equator or reduce to the pole. We see the latitude there is close to the latitude, to the equator, close to the equator. Hello? Hello? Okay, now, how do we do it? First of all, we need to plot our TMI in XY first. Grading, minimum curvature. Now, Z. Now, we'll remove this one. I will now put TMI, XY. Now, the grid size is very important. This is very important. The spacing between the lines. Let me go to, where am I? This one. The specification of the grid. You see it? Line is a tile line spacing. It's around 500. The lines between those ones. So it is recommended that the grid size should be maybe 1 over, I think 1 over 4 or so. I think it should be around 1 over 4, because if you put our calculator, no, it's not one. I'm telling you, flight line spacing. This one, flight line spacing. Flight line spacing. So it is 500 line spacing. So you now say 500 divide by, I think it's 4. Okay, so now divide by 4. So once you divide by 4, you have 125. So it's recommended that your grid size should be around 1/4 and above. It's more recommended. You can go up here on this question mark and click. Other people have done so many work. You can see them here. Do you see it here? See, so this is the help menu under that grid size. You see that? They recommended from half, from quarter, 1/4 to half, right? Normal data sample. If not, the special data point are assumed to be well distributed. So this one are very important once you come to that one. So since it's 125, if I like, I can take 125 as my what? As my grade cell size. Okay, but if I take half of that one, how much is half of this? If I take half of 500, 500 divided by 2 is 250. You see it? How do I get it? Looking down here. You see them? This is recommended, half or 1/4. So now I can now go the half, which is 250. Why do I get that 500? It's from this. Specifications. Flight line spacing 500. Okay? Then now you click OK. Remember it's TMI, XY. Then click OK. Now you see this is our TMI. Now this is an XY. Now we can now reduce to the equator. We have put this one, go to map. Go to this. Before we do that, go to what?
Sorry,
Map. What?
Can I ask a question?
Go ahead, you can ask the question, yes.
Yes. As you were explaining about the line specification from the that's the aeromagnetic.
Magnetic, yeah.
Yes. What if What if it's a ground magnetic survey?
No, ground magnetic, it is the same thing. Ground magnetic survey, because in ground magnetic survey, you set the line yourself, because normally the lines are parallel, because you cannot take data at random point, because otherwise it'd be difficult for the computer to do that grading, because the grading is that you put them along the line, you move along line. Just like you're going towards this side, like this on the ground, you follow the same pattern. You go like this,
Yes.
go like this, you go like line by line like this. The later you cross
Yes.
across. It's the same pattern.
Mhm.
In that way,
So-
it's you that will decide. You have put your point, your mark point. You put a point. You know yourself, you do it. You should have been the ground magnetic that will know what is the spacing between the lines. Because if you do them at that different angles, your point will not be, so the computer will not be able to do what's called interpolation. We have extrapolation and interpolation. Because you have a value here, you have a value here, but what is the value in between? So that is the interpolation. Then what are the
Yes.
value after that? That's why you see, if the spacing is too small, right? When the data was
Yes.
collected, this line spacing is too, so you have a lot of this. But when you do ground magnetic, you find out that ground magnetic, they have high resolution. Why? Because you are going smaller. The more smaller,
Yes.
the more details your data will become. Because that's why the ground magnetic is after you have done the arrow, then you now go deep down to the ground and do more ground. So in that way, you now reduce the spacing. You have more data that were collected. Because this one it's a flight, it's a large way. Cover a large
Yes.
because of sun. And that's the reason why in ground you reduce that spacing. Because it's almost
So-
half kilometers. Yes.
Sorry. So if
Yeah.
we're doing ground magnetic and we're doing the contours for it,
Yes. Yes,
So-
of course.
are we just using the same line spacing that was how the survey was conducted?
Yeah,
on the
yes.
ground?
Your own line spacing. You are the one that will put your line spacing. How you
Okay.
use to maybe like 50 meters or 60 meters. It depends
Okay.
on the size of the place, because you want to cover the whole of the place. You divide
Yes.
it depending on the length of the place you cover it across.
All right.
That's
Okay,
how it
thank
is
you.
done. Yeah.
Okay.
So there
thank
we
you.
divide 1/4. Let me go back. Where am I? Okay, I've done it. Now go to map. One step filtering. Before we go that, we need to go back to specification. The date the data was collected, the range of date. It was not a 1 day. I think it's here. You see it? This is the format. I think this is Nigeria date. Let me see. I think it's around 2007. This is here. This is 2007. No,
Sorry,
it's from
excuse me, please.
this is 2006. 2006 to 2007. Yes.
Sorry, I'm a Nigerian.
Yeah.
If assuming I acquire the aeromagnetic data maybe from geological survey,
Yeah.
will they give me this this information you're showing? Like, does the data come with this same do I call this an attribute data?
All you need
This
to
very
just
one
go
you're
to
showing.
NGSA,
Okay.
Nigeria. When you go there, it's there. This
Okay.
NGSA. When you go there, it is where I download it. You see,
Okay.
somebody was asking India and the rest. You go there, you go under to, I think, services, maps. Let me see. NGSA. I think it's there. If you check down there, I don't know where they place it. I see it here, high resolution. Okay, this airborne database, you can get a geological map and the rest. So that is from there I got it. I cannot remember the actual place, but it's from here I downloaded it. It is there on the site. You can get a specification there. So it's there. So they'll give you, it is there for them, for everybody to be using. So, it was collected between what? This year, around 7th of December to 31st of January, February, March, April. No, April, May. From December 2006 to May. So you can put any range between this range. The data was collected. So take note of this. Then I will now go to map, one-step filtering. This one will open up. The input grid file is remember and projected. Select it. We have this way. Then the next, what do we have next? After that, the name of the output. Somebody's asking question. So now the name of the output is now reduced to the equator, X, Y. Naming is very important. Reduce to the equator. Why is equator? Because the data is collected, it's close to it. If you do to pole, then the grid will look somehow. It's going to be stretched. That means it's wrong. Right? Later, we're going to compare the two. That does not alter the value. It does not alter, but just try to realign the fill at that equator. So now you come to the control file. Is what is used to process it. Control file, you can name it RTE. In this case, they put .con.
Hello?
Yes. Hello? Yes, stop. Who want to ask question? Hello? Do you want to ask a question? Okay, now we put this, name the file this way, then come to filter. When you come to filter, this will open up. You have a lot of filters. Then click the first one. Go down to reduce to the magnetic equator. You see it here? Then this will allow you to put the date, the year. You can take the range of data from this range in between. So why not put it around 2007, 1st January 2001. Okay, the month, then the year. Then click on this to calculate. This was the inclination and declination, the time the data was collected. This one, you can adjust it one, depending to make it exactly the same. You can leave this one empty, then click OK. The everything is set, then now click OK. Now this is the what? Reduce to what? Equator, right? This is what? Reduce to equator. How do we compare the two to see whether they actually have the same value, almost the same value? Right? How do we do that? Is simple. We go to, let's first close them after we have saved. Let's do window, close all, open these two, double click, open, then click on Windows, tile vertically, click on this arrow, then click on this again, click on this. Now they look the same. They look almost similar, but something has been changed, especially around this side. You can look here, you see, it has, you see the shape has changed, it has realigned towards the side compared to what you have here. All that stretching was done. Now it has positioned most of them. There is a lot of changes if you just look at the map. But now, how do you compare the values? Whether they are actually almost the same, but it's not the direction. We'll go to what? Create an image, utilities, point values.
Hello, sir.
Yes.
What is the purpose of reducing to the equator?
The equator, because like I tell you, one of the disadvantages of magnetic survey is the direction at which the magnetic field at which the data was collected. It was not given along with the data.
Okay.
We are just giving data. You see, we are giving data like this. All what we are giving is only X, Y, and Z. What of the direction? It was not
It's
given.
not. Yeah.
But if it's gravity that has not business to do with G, because its value of G is big GM over R squared. Has nothing to do with direction. That's why it's easy to interpret gravity than analyze data gravity than that of magnetic. Direction was not given. So the only way to handle that is to take it to somewhere, we now fix the direction to be vertical, then analysis will now be done in those areas. But most of the assumption is that the magnetic field is vertical. So if you don't use the TMI straight away and get the residual, you may have that error, some of your analysis. That's why it's good to push it there. You can push it to the pole, to the equator, but later we're going to see the difference. Now, what do we do here? We go to create an image, utilities, point value, you see? Point values. Now we select, the first one is the TMI. I want us to look at the TMI. Select the TMI, the first one. The second one, select the reduce to the equator. From there, so from there, what do you have? We click on point. Now, I want to compare this value here with this. Click on this. If I click on this, it's going to compare the value at this location and the value at the same location. Click on the two. What do you see? You see it's what? 80 to 80.5. 85, right? Almost similar. If I click on this one here, you see them?
Yes.
93, 84. If I click on this green, you see it around this. If you go down like this point, of course, you see them? That is how it is done. To not alter it much. It does not change. That's why the shape, the look does not change. So that is the mean in reality, but not the actual value. It has been changed slightly, but the look of the thing, you see them? Look almost similar, almost the same. It has not changed it much. See it? You see it? This one get very close. You see them? 133, 132. And that is how to go about it. No. Now, you see, that's like what I did the other time. If I go to this one, filter. On that, you see this one, you can play with this one, angle, to make the value almost come close to each other. But just leave it like this. Change the value to any angle and do the same thing, you'll see the difference. And that is how to do the residual. Now, so our residual now is this. So now this is our residual. Now we don't need again the TMI. Now this now is not like our TMI, which we are going to now be using. So that means instead of this one that we draw, this one is now our TMI. You can now go ahead and plot reduce to the equation of the TMI. This is the TMI, reduce to the equation of the TMI, residual, regional. And so this is the first map you can do. You can now use this one, right? And now get your map. Okay? Then you can see, for example, how do you plot the map of this? This one is already in XY. How do you do it? Somebody might ask, how do I do it? Since that one we did, it was having database. We switch. How do you do this one? I know end of your analysis, you end up having XY, most of your work. And that is, how do you plot? To plot this one, it's no need to convert anything. Just go there to map. Because we do it inside ArcGIS. You go to map, the same thing, just click on scan grid. Go to this, residual to the equation, okay. Just show you how to then move to next. Scale. Then group this one, reduce to the equator. Then finish. Then go to map tool, draw base map. 5, then 2. Look next. Then this one, since this one is XY, it's not latitude, longitude, so you just leave this one no. You leave the 8 ticks, just change that to be no, because there's no compass direction to projected. Click next. Then you call the REA map. Then click finish. Then you see now, it is not projected as in meters, not in degree. Then go to this, just like what we do the other time. Now select the map, RTE, current map. A map to draw base, color legend bar. Then the unit is this. Locate down here. We are good to go. Then click on this. Click resize. Position it. Then okay. Then file, project, save. And finally go to ArcGIS and save current as this. You see now. Select this one, go to your maps, and now save it. RTE, click save. Then click OK. So wait for some few seconds. It's going to open. So this in case how to do all the other grid. You're going to be doing the same way you're going to be doing like this. Then from here, let's close the window. Close all the window. Save all. You see, once you to do that one, just come back to ArcGIS. Go to what? File. Open. See RTE, then click open. You see, it's there. Now, the same thing we do. We'll click on this. Wait first. It is first loading. It's not yet finished. Click on this. Then click on this. It has gone. Click on this. Click on this. So no need to click on this grid. New grid. Next, finish. Properties. Lines do not show lines. Label. Left, right. 12. Intervals. 6, 0, 6. Apply this. See them? So that is it. See them? So you can do what we have done before. Save. So this is how to do it for all the other maps. You can call it a reducer, just like what we have done. That's how to do it for all other maps in case you want to do it from this and bring them back. It has done all the conversion.
Hello, sir.
Now Said?
Hello.
Hello, I ask question.
Okay, in my Oasis Montaj,
Mm.
there is no, the menu is not updated. ArcGIS menu is not updated.
It's not there?
Yeah,
So
it's
the
not
version,
updated.
which version do you have?
Yes.
Okay, maybe
Six,
is it
6.4, 6.4.
No. This one is see my go to L about. You can see what am I using. You see, it's Oasis Montaj 8.4. You see,
Okay.
8.4 will have everything complete.
The
So 6
problem
point
is the version.
Later, you just contact me. I will give you the link.
Okay.
Where you download that, make sure that there is a place you tick in use ArcGIS plugin. You tick that will have the connection.
Yeah, it's
Otherwise, you
not
see the
updated.
error. So this is how it is done. Now, how do you do the regional and residual separation? Now we have seen those maps. We go now to this, right? How do you separate it? To now get the regional and what? Residual, which is the next step we need to look at. How to do it the right way and the wrong way before you're now able to now sit down and do all of this. The moment you get your residual, then everything else becomes straightforward. So this is what we need to look at. So where we're going to do is to do this one, and then we end at this for the one. After we do the residual and this. So we'll meet next. We're able now to go into details about this, working with the residual. We have know the map. How do you do the regional separation? Well, go to grid and image. Make sure it's open, residual. Go to filters. Go down to trend. Because what is the regional? These are things that are very deep down the ground, that they look almost throughout the whole length of the area. That is regional. They are deep down, right? They appear as a trend. Later we'll show what is that trend. Go to this trend. You want to remove trend from the grid. Remove a trend surface from a grid. You input the grid, right? Then we're going to do two ones we are going to do, right? We'll do the regional, and now compare which one is going to be the best. Let's do it this way. Output grid with trend remove. That means now I'll call it residual. You have now removed a residual 1, right? Residual 1 XY. What do I mean? The trend surface is 1. You see, it's about, about 0, no trend, up to 3. So since we have up to 3, we'll do for 1, we'll do for 2. And so which one are we going to use 1? Are we going to use 2? We'll see. Then you click on 1, right? This will give us what? Regional, the residual. We have removed the trend order of 1. Now let's remove the trend order of 2. Filters, trend. It has picked it up. Just change this number to 2. Bring this one to 2. Right? Then we'll click OK. Now we have 2 grid, right? This one and this one. You see them? You see, I think they look different. You see, they look different. If you look at them very well, they actually look different.
Yeah,
right? Almost the same, but some changes has been made there. If you look at the second order and the first, right? Changes made. So which one is the correct one? Is it this one we did or the one with 1? Then first of all, let's do the regional first for each one of these. We go to grid and image, grid mass. Then now, how to do the regional? This one will open up a expression builder. G0 is equals to, you just click on this, insert variable. You press minus, or you can come to the operators. You look for minus, then you minimize operator. You say G1 minus insert grid value. Then I will tell the computer what is G0. To come here and say G0 is R regional for 1 XY. Then G1, the regional is the residual minus, is the reduced to the equator minus the residual. Our reduced to the equator is not our TMI. Then the first one will now be reduced to the equator, then minus the RS1. We want to do the regional 1 for res1. How does it look like? Click OK. You see, this one, you just name it. This one, you select them. You give it a name, you select it. Then you click OK. Now, this is what? This is the first regional, right? Then let's do the second one. Follow the same pattern, grid mass. In this state, you just maintain this one. This one now you call it 2. This one remain. This one selected to be 2. Right? This is 2. This is 1. Now, regional 2. So between this and this, which one is correct? Is this one or this one? Now, this is what we not to do. Not to do that. The work of this, what is trend? You see, this is what, so this you see, this is trend. That means anything along this side have the same color as you go angular. This is a trend. But the trend here is not linear. It looks uniform, but yeah, it looks curved. That's why it's second order. But first order, it look throughout linear, right? Look at linear as you go. So now, how do we verify? They will have to do what is called upward continuation. You go to map, right? Go to map, go to this filtering, one-state filtering. We'll look at upward continuation. In this case, the upward continuation, you are going to use the residual to the equator. You see it? Reduce to the equator. Then you come here, upward continuation. Let's say you do up to 40. 2 to 40 kilometers. Because that is down 40 kilometers. What happens? Right? They come here, you put UC 40K dot 40K dot con. The name of the file, 40 kilometers down. We want to see what happens there. Bring them to focus. The note for your work, and this is what it does. Right? So this is what it does. It brings data that is down to focus. So this is the app menu which you can read about it. You see it? So this is what you look. Then now the unit is meters because it's projected. 40 kilometers is 40,000, 4 zeros. You cross check 40,000 is okay. Then click OK. Now, if we press OK, what we are going to get, we want to see whether it look like this, one of them. What do you see? Do you see it?
Nothing is new.
Now, let's go to 80 kilometers. Down, 80. Let's go to 80 kilometers. Does it still look the same? If you look the same, that means the pattern, just look at the pattern, how the pattern is going. That is what we call trend. So the trend now is late. Now go to filter. The under filter, you go to this, then you go to this point, upward continuation, then change this one to 8. Then you click OK. Now click OK. What do you see? The same pattern, right?
Yeah.
So that means now among this one, if I now close all, let me open this one. The first regional, second regional, let me take that of 80. Compare them now, window style vertically. See them? Now we have all these ones ready. Which one of these two match this one? I think this is the one, right? This is the one. This one, which of these two matches our upward continuation? I think this is the one, right? Right?
Yes.
So that's why in this case, we use order 1 to remove the regional, not order 2. Order 2 will be wrong because you see towards this side, it's not linear again. Towards this side, they look almost same. Towards this side, it gives us not linear. So this is how to correlate the regional and the upward continuation. So what conclusion can you make here? Now, that is why. So that's why if you come here now, let me show you this one. If I come here, what do you say?
Hello.
Yeah, LOS, you can talk.
Okay, when we say upward continuation, we mean go down or go up?
No, what I mean, it's like a convolution. At a point, you take a data. That data is a contribution from everything down upward. Then now, what we are doing, okay, it's just like somebody give you money. And the money is a collection of people that give you the money, right? The money give you is $5. Or some people give 5, some people give 6, right? Then you want to know those that give high, I want to see them. I don't want those that give low. Where are they? It's just like continue, you're not continue it. So you bring them, those that are 80, show those things that bring the changes that are down to focus. And that's what is that. So this one you are saying, this is what is happening down at 80 kilometers down.
That is downward continuation.
No, that is the opposite, right?
Yes.
So that is the opposite of what you are saying. And this one is bring it to focus. You are not bringing them to focus. So anything that you see here is from 80 down below. Upward, down continuation is from down upward. That's what we call upward down continuation is from down to upward. This upward mainly is from this this down. It's just the reverse of the other ones. That means from 80 down, and that's what you are seeing.
Okay.
You bring them the higher depth, and then
if
take
we
it
are
to focus. And now what is why he's saying is that around 80 that as we are going down, the magnetic intensity is so high towards the southwest than compared to the northeast. That means the potential of getting minerals are more higher towards this side than towards the northeast side. So this area might be a sedimentary area. This because these are lower values, so this may actually be a sedimentary areas around this northeast. But this side will be actually a good site for mineral exploration than compared to this. So this side may be, that means in this nutshell, the prospect of oil exploration is too minimal in this study area. And that is because our study area fall within the northern Nigeria, which does not have the high potential of oil. And that is what you normally see on this map. You see, much of them goes, because this is the lowest you have. So you see spread so much across. But if this blue moved so much, then you now say, okay, this one has gone the way I want it. And that is the way to look at these two must agree with your regional, the upward and the regional. So the regional, this we do is correct. That means there is more of sediments in the what? In the northeast and the southwest. So as you go from the northeast, from the southwest to the northeast, there is the increment of what? Sediment. But if you go down to this, there is decrement of what? Sediment. So the prospect of getting minerals in this study area is very minimal. And that's what justifies your work. And that's how to go about interpretation. You know the geology of the area, past work, that the prospect, that's why mostly construction are done around these areas. Because more of basement in those areas. That's why, because the geology of this area is a basement complex area. So you expect to have this kind of pattern. That is what your work, you have justified some part of your work. So that is how to separate the two. So that's how to do regional and this. So now I can now go ahead, remove this one, and remove this upward continuation. Then remove this one. Okay. So this is what we have. Save, we have save. Now this is our residual and the other is this. So can I double click on it? And I remove that one. And now save it. You see it? We have saved it. Remove this, click on it, double click on it. The name will appear, delete that one, then this. Now everything is saved. Then now project, save. Windows, close all. Then now what we're going to do, whatever analysis we're going to do now is going to be based on this. Right? So this is what we'll be doing next. Now you have plotted the map of this. You can also take the map and plot the map of this, put those towns, take the map of this, plot the same thing, and use this one in order to carry out this analysis. And that is what we will do next. Okay? So I think this is where we are going to stop for now. Except question, you have a question. Yeah?
Hello, Mr. Yusuf. Hello.
Yes, I can hear you.
Hello, good afternoon.
Good afternoon.
Thank you for the lecture so far.
Okay.
And I'm a student of University of Ilorin from the geophysical department.
Okay.
And I've been learning a lot from you. Thank you very much. Just that it has been difficult for me to have access to the Oasis Montaj software. So I'll be grateful if you can share me one so that I can practice all this.
Okay,
and I
so
will be
no
happy
problem.
to also have your contact.
Okay, so no problem. That's why you see on the first slide, you can see there on my first slide, this is the contact, which is there,
Okay.
which you see. So this is the contact, which you see, you are able to get in touch with me in case you need further clarification. Like I said, I think like tomorrow or so, we will now end it there. So for now, I just want you to use the grid I give you to see how you can come up to this far, so that you're now able to proceed to the third part, which is the second part, to now finish just once and see what we are going to see. So now see how to do something like this. In Oasis Montaj. How to get this your spectral blocks. Then how to get this one, to isolate the anomalies, how to do the Euler decomposition and the rest. And that's what we'll be doing to end it up. So what you have done so far is for you to validate, draw maps, separate deeper features with shallow features. So that is one way of the first thing to do. The next thing is to pick one of them you'll be interested in: depth to magnetic source, depth to basement, edge detection of magnetic anomalies. So I think that is all. I think tomorrow I will make it this recording. So tomorrow the same time, right? Hello?
Okay.
So tomorrow the same time.
Same time,
So
same link?
the same time.
The same
The
link?
same time. Yeah, the same link. I'll make it the same link.
Sorry.
Okay?
Thanks.
So we'll do it tomorrow. So just make sure that you practice this once and see. So later it is recorded. It's already recorded. So later I will stop it, and then after it finishes, then I will share the link. So I will send a kind of confirmation message again, where you can now get the link to the video, where you can now download it.
Yes.
And watch what we have done. Yeah.
So may we also get maybe a link to have access to the software too, if possible?
Yes. I'll try. I will just arrange all those links to those softwares, especially the Google Earth is a free, which you can download. You have the QGIS. It's only the I think you have the ArcGIS, right?
I have
ArcGIS.
the QGIS. I have a Q and the Google Earth. It's just the Oasis Montaj and the ArcGIS.
Okay, no problem. I'll try to send all of them, because you need the ArcGIS more than that of the QGIS, because there's stuff that can be done in QGIS easier than done in this. That's why I normally use two of them at the same time. So I will try to compile them and then send them together. I'll down the download link. So tomorrow, the same time.
Yes, thank you.
Okay, thank you all. See you another time.
Thank you for your nice present.
Yeah.
Thank you from Morocco.